Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 17, 2025, just 6 days ago. This paper's standout result is that its new model, Voxtral Small, actually surpasses models like GPT-4o Mini and Gemini 2.5 Flash on key speech recognition benchmarks. The paper is titled Voxtral 2507.1326 4v1, and as we'll see, these models set a new standard for open-source audio understanding. They're designed to comprehend both spoken audio and text, while being small enough to run locally. Alright, so how do these models actually work? This diagram shows the Voxtral architecture. It starts by taking an audio waveform and breaking it into 30-second chunks. These chunks are converted into a log-mel spectrogram, which is just a visual map of the sound's frequencies. An audio encoder processes this map, then an adapter downsamples, or compresses, the audio data. This compression is key to handling long audio files. Finally, both the processed audio and a text prompt go into a language decoder, which generates the final text response. Building on that architecture, this table breaks down the parameter counts for the two Voxtral models. Parameters are essentially the internal settings the model learns during training. What's really interesting is that both Mini and Small use the exact same 640 million parameter audio encoder. The big difference is in the language decoder, where Voxtral Mini has 3.6 billion parameters and Voxtral Small has a much larger 22.9 billion. This brings their total sizes to 4.7 billion and 24.3 billion respectively, showing the performance jump comes from scaling up the language part. Okay, so how do you actually teach a model to understand both audio and text like this? This diagram shows the clever strategy used during pre-training, which is the model's initial learning phase. They break a long audio file and its transcript into smaller, matching chunks. Then, they teach the model using two patterns. One is a repetition pattern, where the model learns transcription by matching an audio chunk to its exact text. The other is a continuation pattern, where it learns context by predicting the next text chunk. Balancing these two was essential. Alright, so after all that training, how do these models actually perform? This chart lays out the results on several speech recognition benchmarks. The key metric here is the word error rate, or WER. A word error rate is a measure of transcription accuracy, counting the percentage of words the model gets wrong, so a lower score is better. And the results are really compelling. Voxtral Small, the dark orange bar, achieves the lowest word error rate on the English short form and Mozilla Common Voice tests, beating even major closed-source models. Moving beyond simple transcription, this next chart looks at speech understanding, so how well the models grasp the meaning behind the words. We're looking at accuracy scores across 7 different benchmarks, where a higher bar is better. And again, Voxtral Small, in dark orange, is incredibly competitive with the big players. It actually surpasses GPT-4o Mini audio on 3 of these tests, like MMLU speech and Trivia QA speech. This really demonstrates that the model isn't just a great transcriber, it's also capable of genuine reasoning and comprehension directly from audio. So a key question then is, does adding all this audio capability hurt the model's original text skills? This chart addresses that directly, showing performance on 5 standard text-only benchmarks. We see Voxtral Small, in orange, performing almost identically to its base text model, Mistral Small 3.1. This is a really important finding. It proves that the model retains its strong text understanding abilities, making it a versatile drop in replacement for tasks that involve either text or audio, without sacrificing performance on either one. So to wrap things up, the Voxtral models are a really exciting development in multimodal AI. That is, AI that can understand different types of data, in this case both audio and text. They've created powerful, open-weights audio chat models, meaning the model's learned settings are publicly available for others to use. They achieve state-of-the-art results in transcription and translation, all without hurting their original text skills. This makes them a fantastic, versatile alternative to closed-source systems. That's all for today's AI Research Roundup. Thanks for tuning in.